Unit 1, Part 6. We're going to talk about scientific notation. So, scientific notation, why is it used? It's used because it makes it easier to handle very large numbers. And when we use scientific notation, you'll see it written in this format. M times 10 to some exponent. So that M is a coefficient. And it's a number that's equal to or greater than 1 but less than 10. Okay, and then you have an exponent, and it's an integer. In other words, an integer, it's a whole number. So the exponent is always going to be a whole number, never a fraction or decimal. So an example, we have 120,000. I can write that as 1.2 times 10 to the fifth. So how do we get that? Well, first of all, when we write the number, let's take the 120,000. And if you look, you're writing it as 1.2. Let's look at this coefficient first, 1.2. In order to get the decimal place here, to after the 1 right here, I have to move the decimal place which starts here, 1, 2, 3, 4, 5 places. Okay, so I just moved it 5 places, and I moved it to the left. Whenever I move a decimal place to the left like this, I'm going to have a positive exponent. So I'm going to multiply 10 to the fifth. So this is saying 1.2 times 10 to the fifth. And that's equal to 120,000. So again, anytime I move the decimal place to the left, it's going to be a positive exponent. Okay. How about if I have a which is less than 1? So over here I have 0.001, 1,000th. And I can, so right here, so I can write that as 1 times 10 to the negative 3. So let's start with that first. I'm going to write this over here, the 1,000th. Okay. And I want to write that as 1 times 10 to the negative 3. So this coefficient, in order to convert this to 1, I need to move the decimal place 1, 2, 3 places to the right. Anytime I move the decimal place to the right, when I'm doing scientific notation, it's going to have to be a negative exponent. So I moved it 3 places to the right, so I'm writing negative 3 as my exponent. Okay? Now, how about if we, so we have, and you can practice these, but these are some examples. And I'll talk about these during the live session, but now we want to talk about, well, how do we multiply numbers that are in scientific notation? So first, when you multiply, you're going to take the coefficients and you're going to multiply them. Okay? And the exponents are added. So let's look at remember the m is my coefficient and the n is the exponent. So we're going to multiply these coefficients and add my exponents. Less than, oops. Let's look at an example. Okay, so actually, so right, we have some other examples here. 2 times 10 to the fourth multiplied times 2 times 10 to the sixth. 2 times 2 is 4. And we're going to add the exponents. So 4 plus 6 is 10. So 4 times 10 to the sixth. And over here, this other one, 5.5 times 3.41 times 10 to the seventh. We're going to multiply these coefficients. So when we do that, we get 18.775. And we're going to add the exponents. 5 plus 7 is 12. But again, we can't have 18. It has to be 1 or greater, but less than 10. So I need to move the decimal place one place to the left. And if I do that, I'm going to add 1 to the exponent. And then we get 1.8755 times 10 to the 13th. How about if we divide? Okay, when we divide them, right, coefficients are divided, and the exponents in the denominator are subtracted from the exponents in the numerator. So it's really the opposite. So this one here, let's look at an example. Some other examples. All right, we have 8.4 times 10 to the 8th divided by 4.2 times 10 to the 4th. I'm going to divide the 8.4 by 4.2. And when I get that, I'm going to get 2. And then we have the exponents, right? 8 and 4. 8 minus 4 equals 4. So my final answer is going to be 2 times 10 to the 4th. And this one here, we're doing the same thing. You have 9.3 times 10 to the 7th divided by 3.8 times 10 to the 5th. If I divide the 9.3 by 3.8, I get 2.4473. And then I'm going to subtract the 5 from the 7, which gives me 2. So my final answer is 2.4473 times 10 to the 2nd. And then we have the same thing here as the last example. Okay? And then what I'm going to do is I'm going to make another video for addition and subtraction. Go here. If I have 5 times 10 to the 4th, okay, and I have times 5 times 10 to the 2nd, I'm going to take the 5 and 5, and I'm going to multiply them. So I'm going to go 5 times 5, and that equals 25. And then I'm going to take the exponents, okay, the 4 and the 2, and I'm going to add those together. So I'm going to multiply 25 times 10, and 4 plus 2 is 6. So now I have 25 times 10 to the 6th. However, if you remember, we said this number here has to be between 1 and less than 10. So we can't write it that way. So what we're going to have to do is we're going to actually have to move the decimal place to make it so that it is between 1 and less than 10. Okay? So what I'm going to have to do is move the decimal place one place to the left, okay, to get 2.5. Now we said that when you move the decimal place one place, or anytime you move it to the left, it's going to be a positive number. So I'm going to have to actually add it to this exponent. And so instead of it being 6, it's going to be 7. So my final answer is going to be 2.5 times 10 to the 7th. 8.6 times 10 to the 6th divided by 4 times 10 to the 3rd. So I'm going to divide 8 by 4, right? This 8 by 4, and that's going to give me 2. And then I'm going to take this 3 here, and I'm going to subtract it from my 6. So 6 minus 3 equals 3. So my final answer is going to be 2 times 10 to the 3rd. Okay? And let's